Hi, I'm an old guy and I do maths. And what we have in front of us is a reasonably complex shape. We're asked to find its area. So let's just take a moment to consider what we've got here. We've got a semicircle. Here we have a triangle. Here we have some sort of rectangle. It's not a square, it's a rectangle. And here we have another triangle. And the area that we're supposed to be finding, I'll just indicate with some red ink. We're looking for this area in here. So let's get to this. Now the ideal method when you're dealing with a complex shape like this is to first of all work out what the principal shape of the area you're looking for is. And in this case, it's a semicircle. So if I just make a small artist's impression of what it was before all of these little bits were taken off it, this is badly drawn, but it's a semicircle with a radius of 1 meter. Now we know that this is a radius of 1 meter because this line here and this line here are of equal length. So this is the middle and this measurement is 1 meter. So in order to work out what this is, it's pi r squared over 2 because this is a semicircle. Okay, so let's just fill in some numbers. So that's pi times 1 squared over 2. Get out the trusty calculator. It's pi times a half, the equivalent thereof. So pi divided by 2, we've got 1.57. We'll stick to 2 decimal places. And this is all in meters, so that is meters squared. Okay. Now, what has happened is a series of shapes have been drawn into this and have removed some of the original area of this semicircle. So let's deal with the first one, which is this triangle here, which is 1 meter by 0.4 of a meter. Okay, so how do we deal with that? Well, that is base times height divided by 2. So the base times the height, 1 times 0.4 divided by 2 gives us 0.2 of a meter. That's going to be removed along with these other areas from this value here. So let's move on to the next one. I'm just going from left to right here. We've got a rectangle that is 0.4 by 0.3. That is simply the height times the width, length times width, however you want to put it. It's 0.4 times 0.3, which gives us 0.12. Now let's get that into frame for you. Sorry, I didn't realize that I hadn't done that. So just to repeat, this is what you see here. The area of it is that times that, which equals that. And the next thing we're going to do is we're going to deal with this triangle here. Now, this triangle, which I'll just draw here and then put it clearly into frame, is this height, which is the same height as this. So that is 0.4, and the length of this is 0.7 of a meter. Now, that is because this whole length along here is the same as this. This is 1 meter. We've taken this off it, 0.3, and we're left with 0.7. So we have, again, base times height over 2, which is 0.4 times 0.7, and divide that by 2, and we get 0.14 meters squared. These are all meters squared. I should have said that. Okay, so let's tidy this up. So we start with our original shape, which is 1.57, and from that we subtract 0.2, 0.12, and 0.14, and that will give us the shaded area here. So this is the calculation, and I'll just do it on the calculator and show you. Okay, so there it is, all set up on the calculator. Push the button, and the answer is 1.11 meters squared. And that is how you deal with a complex shape like this. So just to recap, you find the basic shape, the main shape that you're dealing with, and then you look for the shapes that have been taken out of it. And that's all we did here. Worked out each one, starting with the main one, and then took the smaller shapes out of it. So that is how you do that. I hope that was useful. If it was, please like and subscribe, and I'll see you next time. Bye.